Okay, so we're here today to talk about dilution for EVHS chemistry class on May the 1st. And we should first talk a little bit about what dilution is and why we do it. Okay, dilution is when you take an aqueous solution, or any solution for that matter, but we've been dealing with aqueous solutions. So you take an aqueous solution and you add some water to it, so that lowers the concentration of the solution. Okay, now you may wonder, why do we do this? Well, suppose you're working in a laboratory, okay, and one experiment, you have different solutions of sodium chloride. One experiment requires a 1 molar solution, one experiment requires 2.5 molar, another one requires 5, another one requires 7, another one might require 0.1 molar solution. So you're going to have all these different sodium chloride solutions up on your shelf. Well, that's kind of not a good thing to do, because you're going to clutter up all the shelf space in your laboratory very, very quickly. You don't want to have all these different bottles of sodium chloride up there with different concentration. You want to be able to have just one bottle of sodium chloride up there. All right. In addition, now there's no way that you would even think about this or know this without me saying this, is in a real research laboratory at a university, for example, the professor has to pay the university so many dollars per square foot of laboratory space that she or he occupies in the building. Okay, again, they have to pay so many dollars per square foot of laboratory space. Now, the professor's not paying that out of his or her pocket. They're getting that from research grants. But nonetheless, they would rather use that money to do actual experiments rather than paying rent for laboratory space. So you want to maximize the efficiency of your laboratory space. And you don't do that by having 6 different bottles of sodium chloride solutions up there. You want to be able to have just one sodium chloride solution up there, right? So how do we do that? We make a very, very concentrated solution of sodium chloride, say 10 molar, right? So you have one 10 molar solution, excuse me, of sodium chloride up on the shelf. And then if you need a 5 molar solution for a given experiment, you take the 10 molar down, take some of it out, add an equal volume of water. You have effectively cut the concentration from 10 molar down to 5 molar because you've doubled the volume by adding an appropriate amount of water. Okay, so by doing that, by diluting the solution, you can make any concentration lower than 10 molar, right? If you need a solution greater than 10 molar, you're going to have to make up a brand new solution. But any solution whose molarity is less than 10 molar, you can make from that 10 molar what's called a stock solution, S-T-O-C-K. You can make from this stock solution by diluting it with an appropriate amount of water. Okay, so hopefully now we understand why we do dilution and why it's important. Okay, so this is very, very easy to do. So let's take a look at an example. We'll go with sodium chloride. We were just talking about it. Okay, so there we go. We'll give you a chance to write that down. Let's see a thumbs up once you have it all done. Miss Angelina, you have it? Okay. Now, so let's read this. So we have a word problem, and as we know, it's been a while since we've done word problems. We're going to read the problem and write down on the right-hand side what's given to us and what we're looking for. So we're asked, what volume? Well, that sounds like my X. So volume, oh, sorry. I'm going to write V1 equals a question mark. You'll see why here in a moment. What volume of a 7.65 molar solution? So there's a concentration. Notice, the volume that we're looking for has a concentration of 7.65 molar. Okay, this is again an important consideration here. This unknown volume, what volume has this concentration? So I'm going to write C1 equals 7.65, and I'm just going to use a capital M to abbreviate molar. Okay, a capital M. All right, let's continue on here. What volume of 7.65 molar solution of sodium chloride is required to make 255 milliliters? So here's the second volume. So this is why I put this subscript here, V1, because I have a second volume now. I'm going to draw a line here and write V2 equals 255 milliliters, all right, of a 2.9 molar solution. So there's the second concentration. Notice that this 255 milliliter volume goes with this concentration. You have to get this right. C2 equals 2.90 molar. All right, so the point I'm trying to make here is in every one of these dilution problems, you're going to have two sets of conditions. All right, two sets of conditions. So we need subscripts. We learned this way back earlier in the year, back in September. If you have multiple values of the same parameter, you must differentiate them by using an appropriate subscript. Some books or some videos, they'll have initial and final here. I prefer to have 1 and 2 because it really doesn't matter which one you're calling initial or which one you're calling 1 and which one you're calling 2. Right? It really doesn't matter. But again, the crucial thing is that you match the appropriate concentration with the appropriate volume. The appropriate concentration with the appropriate volume. You have to get that right. If you're going to make a mistake here, you're going to put this 2.9 molar up here with the unknown volume. So you have to make sure and be extra careful that you match the right concentration with the right volume. If you do that, you should be able to solve this problem very easily. All right, now here's my unknown. All right, so my equation is C1V1 equals C2V2. First concentration times the first volume equals the second concentration times the second volume. And again, it doesn't really matter which one I call the starting, the initial concentration of volume, and which one I call the final, whether I do call that with the first set of conditions or the second. The important thing is we keep the right concentration with the right volume. Now, as always, we're going to look over there on the right-hand side and we're going to check off what we know and what we don't know. So let's see here. I know the first concentration. I don't know the first volume. All right, I know the second concentration and I know the second volume. Okay. Now, I always like to have my unknown on the left-hand side, as you well know. So whichever set of conditions has the unknown, in this problem, it's the first set of conditions. So I'm going to put the first set of conditions on the left-hand side. Okay, so I asked the question, is V1 in the numerator? And yes, it is. Is V1 by itself? No, it's not. It's being multiplied by C1. So I'm going to need to move C1 over to the other side, where it will go into the denominator. All right, so C1. Since I moved it over, I can get rid of it here. All right, underneath, I'm going to write what's left. V1 equals C2 V2 divided by C1. So now I ask the question again, is V1 in the numerator? Yes, it is. Is V1 by itself? Yes, it is. So now and only now may I plug the numbers in from the right-hand side into this equation, all right? Because V1 is in the numerator and V1 is by itself. So let's go ahead and do that. Now, I'm kind of having to cram things together because I'm running out of room here. I don't have a whole lot of room to work. So I'm going to write kind of small. Again, you should leave ample space between different lines of the problem. Right? I can't really afford to do that with the limited space I have. So 2.90 molar is C2. V2 is 255 milliliters. And C1 is 7.65 molar. All right, 7.65 molar. Now, we want to see, can we cancel anything? All right, and yes, we can. I have molar here in the numerator and molar here in the denominator. So I can go ahead and cancel that. All right, so now we get out our calculator. Now I have run out of room. Again, you should be flowing straight down the paper, but I have run out of room. So I'm going to bring my work up here. So V1 equals, and again, my only unit left is milliliters, which is that's an appropriate unit for a volume. Okay, so now I get out my calculator. All right, 2.90 times 255 equals, divided by 7.65 equals. Okay, and I get 763. And my only unit left is milliliters. All right. Again, I apologize for cramming everything together and having to come up here, but I have a limited amount of space to work with. So we should stop and ask ourselves, number one, does this answer make physical sense? Okay, we should do that at the end of every word problem. Quite often you can do it at the beginning. Okay, so let's see. We started with 7.65 molar and we're ending up with 2.9 molar. So we're diluting the concentration by more than half. So the volume that we're starting with should be less than half of this. Wait a second, this is not right. That's why we always do it twice. This should be less than 255. This is why we always do every calculation twice. $96.67. Ah, geez. 96.7 milliliters. Sorry about that. That's why we do every calculation twice. Well, I can't put this video on YouTube. All right. So again, we started with 7.65. This is less than half. So the amount that we start with should be less than half of this, which it is. Okay, again, this is a good example of why we do every calculation twice to make sure that you get the same answer, right? Okay, did all this work, I would have had the wrong answer, all right? Any questions or comments here? There should be one or two. If you remember, earlier this week, we learned how to do molarity calculations. And in molarity calculations, we saw that the volume had to be in liters. All right, the volume had to be in liters. That's not true for dilution problems. All right, we can have any units, whatever we want for the volume. It can be milliliters, gallons, pints, liters. Okay, of course, we shouldn't be using gallons and pints in science class. Okay, but it could be deciliters, hectoliters, whatever. Okay, but it can be any unit. Similarly, the concentration need not be molar, right? I mentioned to you when we learned how to do molarity calculations that there's 6 or 7 different ways to calculate concentration. It doesn't have to be moles per liter or molarity. It can be percent weight to volume, percent weight to weight, it can be molality. And we can see here why it doesn't matter what the units are, because they will cancel. They will cancel. Okay, the only important thing is you can have any unit for either volume or concentration that you want. The only thing that's you have to be careful of, you can't have molar here and percent here. All right, you can't have that. Similarly, you can't have milliliters here and liters here. Whatever unit you're going to pick for volume, both volumes in the problem will have to have the same unit. Whatever unit you pick for concentration, both concentrations in the problem must have that same unit. Otherwise, they will not cancel here. Okay, they will not cancel. And I mean, you'll just have a ridiculous answer with ridiculous units. Okay, any questions or comments? All right, so this is it. All right, this is it. It's a very, very simple calculation. Okay, so you can see if one experiment requires 7.65 molar and the other requires 2.90 molar, you only have to have one bottle on the shelf. You don't have to have two different bottles. Okay. So that one bottle that's highly concentrated that you have on the shelf is what's referred to as a stock, S-T-O-C solution, stock. All right, let's look at another one here. Let's see. Okay, we'll give you a few moments to copy this down. And again, a thumbs up whenever you're done copying. It's not very bright. I don't know how you guys can see that. I don't think that helped at all. Is that better? I guess not. Okay, everybody have it? All right, so again, we're going to read the problem. And we want to keep track of the first set of conditions and the second set. It doesn't matter which one we call the initial and the final, all right? Like the first set or the second set. So we have a 1.2 liter solution. Okay, so V1 equals 1.2 liters. I'm going to use just an L for liters, all right, of 2.75 molar glucose. Now I have this volume goes with that concentration, right? This volume goes with that concentration. So this is C1. C1 equals 2.75 molar. So that's my first set of conditions. I'm going to draw a line to separate the first set of conditions and the second set. Okay, of 2.75 molar glucose is diluted to 3.2 liters. There's my second volume. So V2 equals 3.2 liters. Okay, and we're asked, what is the new concentration? What is the new concentration of this 3.2 liter volume? So that's my C2 equals a question mark, a question mark. Okay, and again, before I start over here, I'm going to double check and make sure I have the right concentration with the right volume. So 1.2 liters of this. So 1.2 and 2.75 should go together. All right, it's diluted to 3.2, and what's the new concentration of the 3.2? So we are in fact correct here. Now, my unknown is in this, what I'm calling this second set of conditions. Okay, so I'm going to put the second set of conditions in this problem on the left-hand side rather than on the right hand. So I'm going to write C2 V2 equals C1 V1. Right, let's check off what we know and what we don't know. So let's see, I know V1 and C1, and I know V2, but I don't know C2, right? I don't know C2. So is C2 in the numerator? Yes, it is. Is it by itself? No, it's not. So I need to move V2 over to the other side. So divided by V2, I can cancel V2 there. Right, cancel V2 there. Right, so underneath, I'm going to write what's left. C2 equals C1, just looking on the line above, times V1 divided by V2. Right, so there we go. Now, before we plug the numbers in from over here into this equation, let's get a feel, a ballpark figure for what our answer should be here. So let's see, 1.2 is roughly, it's a little more than 1/3 of this, a little more than 1/3. So we should expect our new concentration to be about 1/3 of this, about 1/3. So somewhere around 0.9 molar, roughly. Okay, so let's go ahead and plug in. So C2 equals, well, C1 is 2.75 molar. V1 is 1.2 liters divided by V2, which is 3.2 liters. Again, you're just looking at the line above to tell you what to do on the next line. All right, 3.2 liters. All right, so what can I cancel? I see liters here and liters here. So I'm going to go ahead and cancel those. All right, my only unit left is molar, which is an appropriate unit for concentration. So again, I have run out of room. I'm going to bring it back up here. You're flowing straight down to paper. Equal signs lined up. So C2 equals, now we get out the calculator. All right, and again, better do this twice. You saw I screwed up the first time. 2.75 times 1.2 equals, divided by 3.2 equals. Put that into memory and do it again. 2.75 times 1.2 equals, divided by 3.2 equals, minus recall 1 equals 0. So I know my answer is correct. Now, how many digits should we have here? Well, I only have 2 here and 2 here and 3 here. So my answer should really only have 2 digits. So I'm going to go with that. 1.0 molar. 1.0 molar. Okay? Again, we didn't have a formal class in significant digits. So if you have more than 1.0, more digits than that, I won't mark it wrong. Okay? But you shouldn't have less. All right? Any questions or comments? And again, we see this is roughly in the ballpark of 1/3 of our starting molarity. Right? Roughly 1/3. Right? We were expecting an answer somewhere around 0.9, and that's exactly what we got. Okay? Again, at the beginning of a problem, or before you plug the numbers in, you should look and see, is there some way I can get an estimate of what my answer should be? Okay? All right, any questions or comments here? Any questions or comments? Okay? All right, so we'll do another one then. Now, again, I want to point out in this problem, in here, the volumes, the 2 volumes were expressed in liters, not milliliters like the last problem. Okay? Almost every problem you're going to do, even in real life in the laboratory, the volume liquid volume will always be either liters or milliliters, one or the other. 99.99% of the time, that's the volume you're going to use in the laboratory. Concentration can be different. I'll use a different unit for concentration in this next problem. Although I think on the assignment that I actually gave you, the only unit I gave is molarity, okay, because we have a shortage of time topics that we can cover due to this coronavirus. So I tried to make it a little easier for you. Okay, but we'll do with a different unit here. All right, there we go. Give you a moment to copy that down. Okay, so let's get started here. An experiment requires 125 milliliters. So there's my first volume. V1 equals 125 milliliters. All right, 125 milliliters of a 12.0% solution. All right, so it's clear that that 125 milliliters goes with this concentration. Again, percent is another unit for concentration, although it could be percent weight to weight, percent weight to volume, or percent volume to volume. And we don't really care here for this problem, right? So here's my first concentration. So C1 equals 12.0%, right, of ammonium sulfate, right? So now here's the second solution, a 50% stock solution. So there's my second concentration. So I'm going to draw a line here to separate the first set of conditions from the second. All right, so my second concentration is 50.0%. Right, a 50% stock solution is available. What volume of the stock solution is required? Right, so it's clear that the unknown volume that we're looking for matches up, is paired with the 50% stock solution. So V2 equals a question mark. V2 equals a question mark. Okay? Now, again, I'm going to go back and double check that. Okay, 125 mils matches up with the 12%. That's what I have here. The unknown volume goes with the 50% stock solution. So we're okay there. Now here my unknown is in my second set of conditions. So I'm going to make my second set of conditions on the left-hand side. All right, and we're going to check off what we know and what we don't know. Over there, I see I know C2, I don't know V2, I know C1, I know V1. All right, so I asked the question, is V2 in the numerator? Yes, it is. Is it by itself? No, it's being multiplied by the second concentration. So I need to move the second concentration over to the right-hand side where it will switch from numerator to denominator. I can cancel it here. Okay, so now we're going to copy down what's left. V2 equals C1 V1 divided by C2. Okay? All right, now, is V2 in the numerator? Yes, it is. Is V2 by itself? Yes, it is. So now and only now may we plug in the quantities from the right-hand side over into the actual equation. Okay? Let's see here. So V2, we didn't make a guess at what our answer should be, equals 12.0% times the first volume, which is 125 milliliters. Remember, you're just looking at the equation above, the line above, to tell you what to put in and where in the next, on the current line, divided by C2, which is 50%. Okay, and can we cancel anything? Well, let's see. I see percent here and percent there. So I can cancel the concentration unit, right? My only unit left is milliliters, which is an appropriate unit for volume here. All right, now I've run out of room. As always, you're flowing straight down the paper. All right, so V2 equals, we get out our calculator. And again, I better do it twice. I don't want to screw it up like that first problem. So 12.0 times 125 equals, divided by 50.0 equals. Put that into memory and do it again. 12.0 times 125 equals, divided by 50 equals. So I get 30. So my calculator shows 30. But here I have 3 digits. Here I have 3 digits. There I have 3 digits. So my answer should have 3 digits. Right? So how am I going to make 3? I'm going to make this 30.0. 30.0 milliliters. Right? 30.0 milliliters. Okay? Any questions or comments? All right. Do we need to do another one? Thumbs up if you want to see another one. Everybody's good? So we think we know how to do this. I don't need to do another one. You sure?
Yes, sir.
Okay. I told you this is pretty easy. Okay, this is pretty easy. All right. So you should be able to go ahead and do that assignment. And it shouldn't take very long. Again, the whole key is getting the right concentration with the right volume. And again, as always, as you guys know, I'm always harping on you. Make sure you do every calculation twice. And you saw I was kind of too smart for my britches there on the first problem. I didn't do the calculation the second time, and I ended up with the wrong answer. All right. But how did I find out it was the wrong answer? By doing what we didn't do here, by checking, does it match our expectations? Well, let's take a look here. All right, I started with 12%, or sorry, I need 12% and 125. I have the 50% stock, so this is roughly a little less than a third. So my volume here should be roughly somewhere between a third and a quarter of what the final volume, which is what it is. Okay, which is what it is. Right? Actually, this is a 4 times. 12 times 4 is 48. So it should be about a quarter, and it is. Okay. All right. So with that, I'm going to end the recording here. Hopefully, you should be able to go off and do dilution. I feel confident in you ladies that you all should be able to do this. And so let me just end the recording here.